Hello. How's everybody doing? Hang on, fellas. I need to shoot out a message real quick if you guys don't mind.
Discovery, go at throttle up.
Alright, cool. Dude, my day has been ridiculous. It's just, yeah, the house stuff, man. Oh, man. Yeah, okay. I see what people are saying when this gets a little nutty. Come on now. I turn the lights on. It gets a little nutty. We'll just leave it at that. It gets a little nutty. Yeah. In a good way, give me 1 second. The negotiations, dude, they get a little crazy. Like, you know, these people want this, these people want this. Like, everything is negotiable, and I think that's cool. But, like, you got to find the line between insulting somebody and not insult. It's, whew, of course, this comes undone. Are things at least going good in your favor? They're going okay. It's going okay. Yeah. You have to negotiate. It's wheeling and dealing and stuff, and like, I can't help but, like, it's not that anything bad is going on. I can't help but think, like, could I have, like, you know, could we be asking for more? But it's just hard to predict. Like, in any other, fellas, in any other scenario, like, you'd negotiate stuff down, but you gotta be careful because it's a seller's market right now. You know, they can always relist and go for more money. It's possible. Like, yeah. See, like, you gotta be careful. You gotta be careful with this. You don't want to be like, well, there's 15 G's worth of problems with this house. That's just a random number. There's 15 G's worth of problems with this house. I need you to knock 15 off the price. And they could be like, all right, somebody else will buy it for that. So, bye. Like, it's a duel. It's like you're at the negotiating table. You're sitting there. It's like, yes. But you don't want to make a downfall. You know, Steiner, you know, you don't want to make a downfall and go bananas. It's, yeah, it's been educational. Yeah. But yeah, guys, just for reference, I might need to dip out, like, in the middle of the stream. If my realtor calls me, I'm gonna be like, yeah, I'll be right back. Primo's like, I hate it. First rule of negotiating. Kill the leader. They won't fight without the leader. I mean, that's Mangalore's from The Fifth Element. I'm pretty sure that wouldn't end well with the pretty sure that wouldn't end well with, you know, the realtor. Just putting it out there. Racer, it's going all right, dude. It's going all right. This is my first time kind of in on the house negotiating process, and it, like, don't get me wrong, I know how to wheel and deal from buying cars and stuff. I can do that. That's no problem. It's just, with houses, it's a little bit of a different animal, so I'm not sure when to be a jerk, you know, and when not to be a jerk. Like, does that make any sense? Be friendly, but have a plan to kill everyone you meet. Mad Dog Matters. Yeah, there you go. Yeah, Sun Temple, I'm trying to... Yeah, we found some things here and there that need to be changed. So You know, we got the first thing, well, we got the first thing kind of negotiated, but the rest, you know, we'll figure out. Like, I don't want to, you got to see how far you can push, but you got to be careful not to push too far, because then they could be like, no. Yeah, exactly, Pop Bear. That's what I mean. I know how to wheel and deal, but this is a very special circumstance because of the housing market, the way everything is. Like, everything is expensive. Like, it's a seller's market. You got to be careful. You got to be super careful. So, like, I'm afraid, like, at the same time, I'm afraid I'm getting hamstrung you know, like, simultaneously. So, like, I'm trying to find the balance, and the balance is a lot, it's a lot smaller of a nominal window for negotiation. Like, you know, if this was, like, 2019, there'd be like, no, you gotta fix this, you gotta fix this, you gotta fix this. I don't need to buy this house. But it's the reverse of that. It's, you know, it's like, well, I'm not gonna fix that. I don't need to sell this house, etc., etc. Like, so you gotta be careful. You gotta be careful. Now you truly own your Subi. Nice, 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 nice. Yeah, so it is what it is. Anyway, yeah, if I have to just back out like of the stream real quick, yeah, that's what's going on. Anyway, how's everybody's weekend? Is everybody's weekend good? There's been some pretty interesting NASA stuff all this morning today. Yeah, there's just been some interesting NASA stuff here and there, like nuclear. Yeah. The Pentagon's DIU award, Developmental Unit, I think that's what that means, awarded 2 prototype contracts to 2 companies. Ultra Safe Nuclear. Oh, do you see how safe it is? They put safe in the name. And Avalanche Energy to demonstrate the next generation of nuclear propulsion and power for spacecraft with the goal of testing the capability in space in 2027. Cool. 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 I successfully wired up a sub-panel breaker box. Nice. We have a Falcon 9 launch tomorrow morning. Yeah. I might have to. I might sleep, W. I'm not sure. We'll figure it out. Yeah. We'll figure it out. If I get tired, I get tired. Like, I've been awake for a good while, guys. For once, I wasn't. For once, it wasn't me like, oh, just waking up like right before the stream starts and trying to fix everything, you know? Like, I've been awake for a little while, just trying to get these negotiations figured out. Like, I'm afraid I may have been a little too soft because I negotiated like right out of bed. Like, I got out of bed, freaking put some clothes on, and then started talking to the realtor and stuff. Like, I'm sitting, like, I'm like, what am I doing? You know? I'm afraid that happened, so I called the realtor back. I'm like, wait a minute. We gotta fix some things, you know? The negotiations will be short. Yeah, I hope so. So, coffee first. Yeah, you're not kidding. That's what I told Brimo. I told Bree, I'm like, next time, let's just make sure that I have coffee before we do this. Communications disruption could mean only one thing: invasion. So, I just thought of something, but Bree, remind me about the thing that I just thought of during break, okay? Remind me of a thing that I thought of just during break. I just had an interesting thing, but I don't want to say it on stream. But I put it out there so you guys know to remind me to remind me to tell Brimo about the thing. You know, the thing. Right? Chat, remind me to tell Brimo the thing, okay? Thing 1, thing 2. Hey, Brimo, remember the thing. No. Brimo will forget, Penta. You gotta remember to tell me. You remember the thing you thought of. The first thing or the second thing? You talked to the guy? You talked to the guy?
Discovery, go at throttle up.
Remember the thing. Okay, Dragon. I just had an interesting thought. You know what? Give me 1 second while Kerbal is loading up. I'm just going to tell Brimo the thing right now. We will tell Brimo the thing right now. An interesting point. Yep. Huh. Okay. Cool. If that transpires how I think it's going to transpire, I will let you guys know. Dude, I can't decide whether negotiations are fun or not. Like, I can't. It is fun. I like the wheeling and dealing. I don't like this whole seller's market kind of screwing with me a little bit, but I do like the wheeling and dealing. It is kind of fun. It's fun when you win, yeah, but you have to be prepared to lose. It's like a poker game, you know? Did I click on the mission mode save out of habit? Oh my gosh, I did. let's just go back. No TTT in the title. Yeah, it's because I don't want to play Tarkov with you. Because I don't like you. You're a dick. I changed the title up, man. Honestly, I've been busy with house stuff. I was just like, and then Tarkov, frig it. I am what I eat. I self-burn or something? The way I see it, negotiating large cast numbers is akin to eating a super spicy chicken wing. Both sickening yet thrilling, but you but you end up both with a high and a desire to never do it again. Yeah, no, it is like that. Yeah, it's fun. It's fun, but it's also, yeah, it's, you know, Kyron, it's kind of like that, like, or like getting crap, getting crap. This is like Tres Comas, all right? Tres Comas was really, really fun. It was really fun until the next day when it really wasn't fun. It was really fun up until that point. Yes, I keep that bottle very close to me. All right. Anyway, let's get working on that MLV, shall we? Shall we? Let's shall. Alright, so we were working on the hold down points for this. I had this all designed, and what I'm gonna try and test today, guys, is fun until it wasn't, pretty much, or not. Yeah. I mean, see, the other thing is, like, I'd be lying to you if I didn't say that I didn't want it. I really want that house. But you gotta be careful. Like, my realtor and everybody's telling me, like, you gotta know when to walk away. And I'm like, yeah. This is like a super high stakes poker game, man. I just hope we don't lose. That timing you in chat last night was great. I had a bunch of streams on, dude. Fellas, what I actually ended up doing was, I was playing Railroads last night, and I ended up redoing a good section, a good bit of track. Not anything on the existing lines. I redid the track all the way to the ironworks. Well, not redid it. I just cleaned it up. I cleaned it up a little bit. The track is still exactly the same. I just went through, got rid of all the X's, cleaned up a lot of groundwork, and then I started putting a Y into the to the oil refinery and stuff. And that's when I was just like, yep, I'm tired. All right, Ernock, drive safe. Does the shell occlude the engines? It should, Hypersonic. We still have to do tests and stuff, but yeah. So yeah, I did a little bit of homework last night. Yeah, Warrens, I noticed some things with the track that wasn't completely level, so I ended up leveling it all out and straightening it all the way. Don't get me wrong, it was like 98% right. It was just like running in the groundwork and a couple of things here and there. Trust me, dude. It looks good. It looks good. Yeah. The track dipped at some point, and my guess is when you ran a line from the ironworks forward and then connected it in at the corner, right? That's what I think, right? I think that's how it worked, and there ended up being a little bit of a change in height. I unified the height all the way to the ironworks, dude. It looks cherry, man. So it's your lines. I just raised it a little bit and made it nice, and it's nice and true, dude. It's like, trust me, you'll go in and you'll be like, oh. Can you explain how occlusion works? I know the weight still affects drag. Does it really reduce the drag modifier of the parts inside? It takes the mass value of the part and applies it to the fairing, Hypersonic. Yeah. Yeah. Like coming from the refinery into the ironworks. Coming from depot into the ironworks, dude. I didn't get further than the ironworks to refinery. I'll have to show you, dude. We'll play mañana. It'll be, yeah, dude, you'll see it. Trust me, it's not that big of a change. It's just, I just cleaned it up. That's all. I just went through, you know, you said like, oh, you got to lay all the groundwork. So I laid all the groundwork down. Trust me, it looks cherry. Now I kind of want to show you, but we'll get that done tomorrow. So fairing just has less drag than an engine for the same weight. Yeah, pretty much, dude. And then I started putting in, Warrens, I started putting in the Y to the oil refinery. So I started laying in the switches. So I have, if we're looking towards the ironworks, so like we're going towards the ironworks. So we're coming from the freight depot looking at the ironworks, right? I have a left to right switch, right? So we have a left, right, you know what? I'll just draw it. It's easier. So, right, we have the depot. Tracks go down here like this, and then we make them turn, and they go to the ironworks right here. And then there's the oil refinery, right? This segment of track from about here to about here, I just leveled and groundworked it out. And then right in this section right there, so that's north. This is north out of the depot, right? The roundhouse is right here, and then the loop is right there, right? So this segment of track is what I'm talking about, right here. So if we're coming down on the tracks, I did one of these, right? And then I put in the lefter, and then we did another one of these, right? And then I put in another lefter, like that. I just laid in the switches. So the left, right, and then the other switch, so we can make two tracks go this way to the oil refinery. That's all I did. But yeah, it's coming along, dude. Trust me, it looks good. I made sure we did it right. Yeah, basically hypersonic with the fairing, it just, it takes the mass of the object and applies that to the fairing. And if the fairing has more mass, right, it's going to create a little bit more drag, but not as much drag as if these parts were flying out by themselves. Yeah, it should be good ones. So what I want to do, I wish I just kept that drawing up. What I want to do is make a triangle Y. So it would be like this for you. Triangle Y. So the oil refinery is right here. We make the triangle, and then it goes down to the ironworks. Just basically a branch line to the ironworks with a triangular Y, so you can go different directions. We can come in from the freight depot or come in from the ironworks side. That's what I'm trying to make. So do you have anything specific you want to launch with this bad boy? This is going to be used for our mission mode 2. And actually, all right, guys, flipping the page off of trains for a second. So, we have a release date for KSP 2. Well, kind of. We kind of have a release date. So, KSP announced that they're cramming the universe into a game is hard. KSP 2 will now launch in early 2023. So we got a new release date for Kerbal, and it's 2023. So here is what I'm thinking. By the time that game comes out, I want my mission mode saved to basically have done everything. Okie dokie. I want architecture that's going to get us further into space, that's going to explore the entire system or go wherever you guys need me to go, right? So, are you giving us permission to get hype? No, you can get permission to get hype. Hold on, I got a text. So, what am I designing this vehicle to do, KSP Addiction? I'm designing it to basically be the end-all, be-all. A vehicle that does everything that I want, everything that we've learned over the past 10 years of playing Kerbal. I want this vehicle to do everything. Not do everything, that's not really the right way to do it. I want it to be like a swan song for KSP. Ah ha ha, sure. Man, why you gotta hate like this, man? I'm trying to make magic happen here. No further than Duna. Suka. Shut up, man. I'll get us past Duna, I swear. The haters gonna hate? Nah. There's hate, KSP, and then there's truth. And you know what? Truth hurts more than hate. It's true. Oh my god. It's true. Truth hurts more. It's freaking true. I hate hearing something that's the truth that I don't want to hear. Haters, at least I know, are full of crap. You know, it freaking hurts, man. It hurts. Oh, that's good, John. How are the legs coming? I decided to switch to work on the hold down points before we work on the legs. So that's what we ended up doing. Or that's what we're going to end up doing here. So we have same vessel collision enabled on that. There we go. Save. So the next thing, you know, like, believe it or not, the next things that I kind of need to do here are to figure out how to move this dang thing. Start from Elu. Yikes.
Discovery, go at throttle up.
Hey, Jaeger. Good morning, man. Hang on. Mouse wheel isn't working again. It's just dust getting caught in the sensor. Come on, mouse wheel. There we go. Alright, so I want to basically see today that we can work on I want to basically see that I can hold this up with physics-less parts. I have a theory about these parts. The physics-less parts, I think we could get... I think we could use the physics-less parts as hold-down points. I think.
Our first stop will be on the grounds of the world-famous National Palace Museum, which houses Chinese treasures dating back some 4,000 years.
Well, let's hit the road. So, yeah, we're gonna have to... Oh, come on now. Alright, so I really want to make sure that this thing can actually be held up. And then what we really need to do is figure out a way to turn this thing upright and put it on the... on a stand. And this comes with the process here, like... You know, this goes into how the first stage should be put together and whatnot. Like, how are we going to make this? How is it going to be put together? What do we want to do? Do we want to vertically land it? Do we not want to vertically land it? Like, there's a lot of interesting tests here. I'm going to take this and I'm going to put it up here. Just because it's a part for placing stuff in the editor. It's not necessarily for flight. So, you know what? I think because I'm already using engineering mode to design this vehicle, we don't necessarily need to do all the tests the same way that we do them in mission mode, but I should still have to qualify this thing in mission mode either way. But in the spirit of getting things done, let's excuse me. Let's try something. So what I want to do is I want to develop basically a stool for this thing. I want to see if these hold down points actually work. So let's put a tail service mast, a TSM mount right here. Tail service masts on rockets are used basically to connect into the rocket and allow the flow of commodities. So like flowing fuel, electrical power, HVAC. Now in Kerbal, all we really need to worry about is just fuel and probably a little bit of electrical as well. So I'm going to put the hold down point. We could put it down here, but I think it's much more reasonable to have the fueling point right here. The reason why the fueling point needs to be there is because usually it's on top of the hold down point. So that's no problem. So now what we're going to do, hit spacebar, let's go. Okay, I'm hitting spacebar. So now what we're going to do is get rid of docking port force there, auto strut these, make sure they're auto strutted correctly. Alright, so now we need to find a way to hold this thing together. I've found in the past that putting parts symmetrically around a ring seems to be the right move. So we're going to go into structural and give me the T50 structural tube. Okay, I'm going to try to make this hold down point in a very, very specific way. I have a theory on how it's going to work, and we're going to prove it. We're going to prove to see if it works or not today.
Discovery, go and throttle up.
Alright, so let's rotate the entire booster back to upright orientation, and then that should be rotated on a transform. We gotta just check for our clearance, Clarence. Okay. You're a new launch vehicle. Destroyed. Atlantic. 5 month on a 3-month streak. Thanks, man. Alright, so now what I want to do is give me the hold down points here. And honestly, put these in 4x symmetry. And I want to see if this holds the rocket up. Okay. Interesting. We're not getting an absolute snap because my docking ports are offset at 45. Now, what happens if we do this? And I put the hold down point, or I put the tail service mast attachment point right on top of the hold down. Well, if we did this, this is going to have to rotate out of the way. Interesting. Something is not aligned here. Oh, there we go. There it goes. All right, now we're aligned. So what I want to do is basically put this booster out, and I want to see if it holds. The only thing, so right now, the only thing that will be structurally holding this up, like via physical connection, is that docking port. I'm going to rely on same vessel collision on these parts. And I want to see if same vessel collision holds this thing. I'm genuinely interested. So what I'm going to do in the meantime is just run a couple struts to make sure that that's held in place correctly. right? I just want a picture of a gosh dang ha 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 dog 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 dog. All right, so we also need a pedestal for this, and let's just make the pedestal as simple as we possibly can. Oh no, I want these twice removed like this. So here's what we're gonna do. This is a really important point in the development of a vehicle, especially in Kerbal. Like, if you're going to try and make a launch pad or something, this gets really complicated really quickly. You got to be very careful. And the reason why you got to be careful is because, well, this interfacing point is, there's going to be a lot of mass riding on this thing. There's going to be a lot of mass riding on it. Literally, the weight of the entire vehicle is going to be on these 4 hold down points. So I got to be sure that these points are extremely strong. So what we're going to do is this. We're going to go here like this, and we're going to do one static test with our booster here. My name is Jeff, 54 months. Thanks, man. We just need to make sure the booter can be held up. You guys know, the booter. So the next thing that I'm going to do is actually going to take these and put these here with a lot of mass, and I'm going to attach these counterweights to this piece, right? So when we go to rotate these things into position like this, they're holding the booster down, and if we auto strut it, it'll strut to the main plate. All right, so make sure this thing has no fuel in it. Let's just see if it can hold up the booster. I'm wondering how my triple frames are gonna work, but all right, let's go. Let's see what she does. Verb. Alright, so we're going down here. Let's hit 1. So that turned on same vessel, and now we disconnect these. Hey Vickers, thanks man. Shh. Flyover got canceled due to an oil leak. Oof. Wow. That's really strong. Okay, that's really strong. Yeah, now fill it with fuel. Well, yeah. But we gotta be careful. We don't want to shock load this thing, 95, right? Like, we don't want to do that. So, what I think we should do is 1, 2, 3. We should get 3 of these fuel tanks, right? Hello? That was strange. I'm gonna really test this now. I want to make sure. I'm gonna make that docking port detachable. We're really gonna stress test this. We'll put it on a robotic, and we'll see what the robotic does. Right? I don't think we're aligned. Are we aligned? Yeah, yeah, we are. Hey Pearly, can I build the Rust Lighthouse on the island I'm at in the Minecraft server? The Rust Lighthouse. Yeah, that's fine. Yeah, go ahead, man. Yeah, I did some work on the helicopter pad too. Got the started to get the pavement in. City's coming along real good. 48's building down here, looks really nice, and people are starting to weed in other buildings in there, which is actually pretty damn cool. Yeah, no problem, man. Of course. Alright, let's try this again. Got a whole plan for the beach shoreline coming. Sweet, man. I appreciate it. Thank you. Yeah. Life's a beach, 95. Dig it. Remember that. Life is a beach. Dig it. Damn! Jewel's like, I don't think that's how that works. actually, you know what this is lending pretty good credence to? The fact that we can hold SRBs in place. Believe it or not, this is actually pretty cool. Alright, so here's what we're gonna do. This thing's out of fuel. Hit 1. Disconnect. Undock this. Now, go back down to the pad, quote unquote, and move this out of the way. Right, so what happens when we bring this back into position? Whoa. Wow. Okay. All right, here we go. Let's try a fueling procedure. Okay, fueling umbilical works. That's actually really cool. And you know what the crazy part about this? This hinge shouldn't drift. It shouldn't drift at all. The reason why it shouldn't drift is because it's not holding up anything. It is passivated because the hold down points are the hard attachment points. That's what's holding things up, not the umbilical. That should help us with hinge drift. Alright, let's watch these points here. Oh, she's starting to move. What's going on with this thing? Alright, let's keep going. I wonder what all the rocking about is for. Oh, it's stopping, whatever it is. It's dampening out. Not dampening, it's not getting wet. It's damping out. Wherever that vibration came from. Starting to get unhappy. It's dampening because the interior is dampening. Sloshing maybe? Well, there's no fluid dynamic simulation between the tanks apocalypses, which is interesting. Wow. These little thermo bearings are strong, man. They're strong when it comes to a compression load. That little thermometer is holding this whole thing in place. If that thermometer broke, the whole thing would come apart. That's actually really cool. I'm really impressed. Alright, now here's the real moment of truth. Ready? Boop. Oh yeah, see, it's getting unhappy. Let's zero that out. See if it redocks. Wow. Yeah, I see it, Banana Time. It is moving around. We might need to come up with a little bit of a stronger point. But the fact that 4 RCS balls are holding this thing up, it's a theory that I have about physics-less parts. Physics-less parts were strong. We know they were strong to begin with when we did Kraken Tech with them. I lifted a space shuttle up with Kraken Tech hinges before, right? Here, let me pause the simulation. We've done that. We know they're strong, but because they're physics-less. What does physics-less mean? A physics-less part in KSP is a part that's too small to really warrant its own simulated physics. So what it does is, when you attach it, it applies its mass characteristics to the part that it's attached to its parent part. So if I have an RCS ball, right, that's like 1 kilogram or 2.2 pounds, right, and I attach it to a 100 kilogram fuel tank, the game doesn't think of it as a 100 kilogram fuel tank with a 1 kilogram RCS ball attached to it. How the game thinks is that this part is 0 and the tank is 101 kilograms. That's how it works. So physics-less parts, so to speak, once you apply physics to them, they don't necessarily behave like a regular part would. They don't behave like regular parts, and that's good because look, that thing is straight up 4 RCS balls with a bunch of physics-less thermometers are holding up this entire first stage fully fueled. Now, don't get me wrong. Second stage and payload, I'm pretty sure that that's not going to be happy. But these physics-less parts have proven to be very, very, very strong in the past. For instance, lifting an entire Condor stage up. See, it's proven to be pretty damn strong because I was using a physics-less hinge. I was using Kraken Tech hinges for this. And then Zerora, you love space? Yeah, me too. I like the engineering behind it. What I'm trying to do is make hold down points for my new rocket. I want my rocket to be reusable, so I need to make a reusable pad for it too. What I'm trying to see right now is how strong this mechanism that we just made is, and I'll tell you what, I have 4 RCS balls that are being held in place by thermometers, holding this entire fully fueled rocket up. That's pretty dang cool. Physics-less parts make a very good hold down point. Cubic octags, RCS ball, thermometers, fluid spectrometers, they make very good physics-less hold down points because they're not susceptible to physics. So when you try to make a physics-less part susceptible to physics, it turns out to be very strong. That's what I'm figuring out now. Hey Velox, how did the Artemis wet dress rehearsal go? They found some problems, but they're fixing it right now. Targeting end of July, probably August for a launch. Remember, it's not necessarily about when the rocket is ready. The rocket can be ready. If the moon ain't in the right place, then it doesn't matter. Would doing the hold points in 8x symmetry help? Yeah, John, but we gotta be cognizant of other things. There's gonna be landing legs in this spot. Between the A, B, the C, and the D, there's gonna be landing legs here. So I would prefer to come up with a stronger 4x hold down solution here. Actually, this downward facing pin and latch system is borrowed from a Titan II. That's a Titan II's hold down system right there. Only the RCS balls would be explosive bolts.
Discovery, go at throttle up.
Wow, somebody made one out of Legos. Yeah, this is straight up borrowed from a Titan II launch pad. If we can look, that's the last Titan II that ever launched. See, it's 4 hold down points. Are the balls attached to the tank or the panels? It's actually attached to the engine section, Granite. Hey, Astromark, that's a tier 1 sub. Welcome to Mission Control, your go at throttle up. Thanks, man. I appreciate it. Yeah, Titan has 4 pins at the end here. Where can we see a close-up picture of a Titan? Here, let's try LR87, which was the Titan II's first stage. See if we can see a picture of it. Yep, there they are. See? 4 pins. And those 4 actually, I never noticed that. I never noticed this about a Titan II. Look, the hold down points are straight up integrated into the engine mount for the LR87s. And it really pains me to see somebody just spray painted over an LR87 like that. That's really annoying. Yeah. You guys know, like, when you see a nice car driving down the street and it's very clear that somebody did their own paint job on it, and you're like, they probably painted it to preserve it because it's outside, to be honest. But LR87s are supposed to look like that. Pretty cool, huh? Interesting thing about LR87s. This is called the LR87. The LR87 is not one engine feeding two nozzles. That's two motors right there. You have two sets of turbopumps. Yeah, you have two sets of turbopumps for this thing. So it's two motors, and each motor by itself is called an LR87. But the motors working together like this in one component is also called an LR87. Little weird, but it works. I've hugged one of those, you know. Look at that. That's aesthetic as hell, man. That looks so nice. Yes. Oh, see? That's what it's supposed to look like. That's nice. So a single one is an LE 43.5. Yeah, right? Actually, another fun fact while we're here. This one is that one looks to be the one that's at the Titan II missile silo. 571-7. The museum. There's your fueling umbilicals right there. Titan was literally fueled up by a hose. You just plug a hose into the side. Well, not that simple, but pretty much. Hey, I found your stream over the weekend. I really like your content. Glad to be here. Thanks, Mark. I appreciate it, man. Yeah, I'm glad you like it, dude. I really like getting into the nitty-gritty of engineering, especially when it comes to launch vehicles. Like, I like space, but I like I like space engineering more. That's really what I try to focus on. So this isn't your typical like, hey, did you guys see the lunar eclipse last night? Now, that's cool. Don't get me wrong. But I'm really more interested in like how a butterfly valve works on an LR87. You know, the butterfly valves were the linchpin to this whole design, and that's on purpose. Yeah, single fault redundancy on the fuel lines for this. Does anybody know why? Actually, just on a side note, does anyone know why? Did you get some wicked storms? We had a little bit of a thunder boomer come in, yeah. Anybody know why the butterfly valves on the fuel lines here are the linchpin to the whole design? It's single fault redundant. If it fails, the thing doesn't work. Anybody know? I'm just curious if anybody knows why. Why would you do that? If that thing pops, the whole rocket blows up. Anyone? Butterfly valves can be used to throttle, but mainly full open and close. These ones on this one, Nerves, are full open and close. It's not like a throttle body on a car. It's just the butterfly valve is open or it's closed. Self-destruct mechanism? Do butterfly valves fail often? They don't, Maggie. One person said it. John, you said it right. The butterfly valves were the linchpin on a Titan II on purpose. Because the whole rocket won't work without those butterfly valves to work. Now, guess what? I've been reading a lot about Icbms lately just because I'm kind of interested in how you launch a rocket inside of a silo. Like, that's a lot of gas to get away from the vehicle in not a lot of space, right? It's actually pretty interesting when you think about it. The butterfly valves were the linchpin because the nuclear launch codes for the Titan II weren't the nuclear launch codes to launch the missile. They were the nuclear launch codes to open the butterfly valves. They made it single fault redundant on a Titan II. Specifically, they made it that way on purpose so no one could launch the rocket without the codes to open up the valves. Basically, they can't do thermal conditioning on the motor. They can't prime the engines without the valves opening. That's why they were single fault redundant. So if anyone tried to go screw with it, right? You tried to screw with the butterfly valve and open it up, it wouldn't work. They had to have the codes. If you tried to like mechanically do it, the thing breaks. Yeah, single fault redundant on purpose. Yeah, it's really interesting stuff. If you guys go to the Titan II Missile Museum, they talk all about it. The butterfly valves, yeah. And if you didn't type the right code in to open up the butterfly valves, if you typed it in wrong like 4 or 5 times, the computer fries itself. Yeah, it's actually pretty cool. And if you tried to like go screw with it mechanically, the butterfly valve would break. Yeah, they did that on purpose to make sure that nobody goes rogue and tries to launch a missile, just ending the entire world, which is actually pretty cool. I like the UX, the UX of nuclear warfare. That's very interesting to me. Does it Philip J. Fry itself, basically? Yep. Yeah. It's a really, really cool design. Yeah, there you can see them actually here in the rocket garden, right there. Now, keep in mind, this is a GLV. So this is the one at Kennedy. So because this is a Titan II GLV, it doesn't have the nuclear butterfly valves. It just has regular ones. They're right there. See them? They just look like a washer from the outside, but it has a butterfly valve in it that opens and closes. Now, what's a butterfly valve? You have like a cylinder like this, right? And inside of the cylinder, you have a hinge that goes left to right. And then you have a valve that's shaped like a circle. And that valve, if you're looking at it from the front, it's like this, but if you rotate it 90 degrees, it basically looks like this. It's a valve. It opens and closes. So this thing can rotate forward. If anybody here is a car fan, a throttle body is a butterfly valve. So LS throttle body. That's a butterfly valve right there. See? It's a plate of metal, right? And it's screwed into a hinge. And in this case, the throttle on a car, this is what Nerves was talking about. A throttle on a car is not just open and close. If it was, it would be full gas pedal or no gas pedal, right? And when you push on the gas, it pulls on a cable in this particular design and opens the valve, so it allows more air to get into the engine in this case. But there are electronic versions of it too, but it's basically the same thing. Only one's designed for liquid, so the ones that are designed for liquid have a seal in it. Yeah, interesting, huh? So anyway, these points are borrowed from a Titan II. I used the Titan II style hold down point. Hey T-Man. So let me undo the rocket again. Let's see. Retract the umbilical and see how well it holds. Yeah, see. It's not happy with us right now. Ready? Well, it got away. It slipped out of the hold down points pretty well. I probably should have zoomed in. And now we're flying and I'm not sure what to do. Maybe I can land it or something? See how good your boy is at being a flight computer. See, I'm not even watching the vehicle. I'm watching the nav ball. I'm watching the nav ball for descent rate and where I'm going. This would be really useful if I had an altimeter down here. If I had the ground altimeter down here, I would never need to look around. What was the TWR off the pad? I'm not going to pay attention to it so much, John, because we have no upper stage attached to it. Oh, hey now. Come on. Minute corrections. Come on. we're gonna crash. Too much lateral. What do? We die. I suppose while we're here. Oh yeah, hold down points don't make that much. Okay, cool. Yeah. I'm pretty sure this thing would have structurally eaten itself by now. A lot of gimbal. Nice, not bad. Funny thing is, we just did a Titan 2. When in doubt, throttle it out. Indeed. Man, this thing's got some kick to it. Look. This is the first time I've really seen the thing fly. Look at this thing. Come on, get to the ocean. Wow. Uh-oh. We have no RCS. Let's just hope that the thing stabilizes out. What's our apogee? Our apogee's at 90. Oh no. Here, let me turn the engines on again. Turn the engines on, see if we can get it to go in a different direction. Come on, you. Just have to do a little bit more of a prograde burn here. All right, that should be good. All right, so let's do this here. Hang on, let me, if we're gonna do this, we're gonna do it right. Let me go in here and set, oh, frick. Okay, yeah, well, it's one engine or nothing. I don't think we have enough fuel. We have 400 fuel. This thing is going to crash. The booster did self-stabilize, actually, which is pretty good. That's what it should be doing. But yeah, we might have to, the whole re-entry thing. Supersonic retro propulsion. Yeah, we don't have enough to stop this. This is gonna, yeah, we're not slowing down fast enough. Maybe if I just like turn on some engines here and hopes that it, you know, won't do that. Yeah, it did that. Go get the truck. Yep. All right. So that test was actually pretty good. I think we need to mess with our hold down points a little bit more. Dust. Yeah. These are good. That was actually remarkably strong, but they were jittering around a little bit. So how not to land an orbital class rocket, yeah. If I had an attitude control and stuff, I probably could steer it in, but actually that thing performed pretty dang well for what it was. I was a little bit worried about the 2 degrees of gimbal. 2-degree gimbal vector with the skippers is not very good for precise landing, but I think it can work. Yeah, drummer. Yeah, physics sim screwed that up. Yeah, but this hold down mechanism actually is working really well. I'd be interested to see if we could engineer something a little bit different here than a Titan. Here. That's SpaceX's. SpaceX uses a hydraulic to get lateral motion. Interesting. And then SpaceX has a pin hold down point. The hold down point is right there if you want to see. It's like it's a little pin. Oh, wow. There's Saturn V's.
Discovery, go and throttle up.
Wow. That's pretty damn impressive. So, okay, guys, I want to point something out. Just, why am I like, wow, that's crazy? I'm saying that's pretty dang nuts because Saturn V's hold down points were on a hinge. They were on a hinge. Now, see the fixed pivot right there? That's the pivot point for the entire thing. It's basically a lever arm that holds at 12, 3, 6, and 9 on Saturn V. And then when it went, there's a counterweight on the back and the whole thing folds up into the hood and it closes. But is this an... Yeah, no, it is a hold down arm. That's actually pretty damn impressive that the Saturn V has an entire pin, like a hinged mechanism holding it up, considering how heavy that thing actually is. That's pretty damn good engineering. Yeah, see, it attaches to that point right there. See that little buckle? Yeah, see, little pin in a slot, same thing. Freaking same thing. Imagine how strong that... I mean, look at that. That pivot point can't be bigger than a baseball. Or not pivot point. That pin. The latch can't be bigger than a freaking baseball. Imagine how much how much force is getting pushed down on this thing when the thing's fully fueled. Think about that for a second. The Saturn V has 7.5 million pounds of thrust. It's about 35 meganewtons for the metric folks. 7.5 million pounds of thrust. That means that the Saturn V, fully fueled, with all the payload and everything in it, well, we know it doesn't weigh more than 7.5 million pounds, because if it did, you'd fire the engines and the thing wouldn't go up, right? So, somewhere in the ballpark of like 7.2 million pounds of force is being pushed down on this thing from gravity, which is absurd. Okay, so you split that over 4, right? That means a point the size of a baseball, right? Literally about the size of maybe a baseball or a softball or a grapefruit for people that don't know how big those are. So you divide 7, let's say, just for argument's sake, let's say it's 6. 6 is easier to divide. That's 1.5 million pounds of force on each hold down point, which is absurd. What else do you know that's about this big can hold up? Well, I mean, if it's 7, it's closer to 2 million pounds. Something this big holding up 2 million pounds, because there's 4 of them, which is unbelievable. That's really damn impressive engineering. That's pretty good, man. Doesn't get better than that. Hey, Sneaky. So these pin hold down points seem to be working. They do freak out a little bit, which is why I'm wondering if we could do something better. Yeah, Mark, we had pretty good control authority. Now, don't get me wrong. I don't know how that's going to work with the moment of like an upper stage and payload on top of this. This thing is designed to have RTLS capability, so I want to make it kind of like Falcon 9, but more my own design. This thing is like somewhere in between New Glenn and Falcon 9 for what I'm aiming for. Think of like if we took a Saturn 1B and like tried to make a vehicle like Saturn 1B today, how it would end up looking. This is, or like Ares 1, it's supposed to be synonymous with that capability. Now Kerbal is about 60% scale when it comes to your Delta V, or like vehicle scaling, and so if I make something, like theoretically I make something 60%, like 2/3 scale of its real life counterpart, it should work just fine in KSP. So, you know, Saturn V, Ares 1, Delta IV Heavy, they're all designed to move about 25,000 kilos into space, or about 50,000 pounds, give or take. It's more like 55,000 pounds. This thing should, you know, scale that, give or take. It's about 18 tons. So that's about 40,000, no, not 40,000, 38,000, somewhere in there. That's what it's supposed to do. So, yeah, I mean, you don't know what it's going to do with 18,000 kilograms of payload up top, the fairing, and the second stage up there. But the control authority did seem okay for what this is. That actually gave me some pretty damn good confidence. I actually don't mind I don't mind the small gimbal authority. That'll make it easier to do precise landings, believe it or not. Because then I can rely on aerodynamic control authority for when I put grid fins on this thing, or whatever type of vector mechanism we use to move it, right? If we put grid fins or something on it, I can rely on that to be more precise, and then the rocket is just for making minute adjustments at landing. I mean, which is basically what Falcon 9 does. Rockets get very unstable in the last 5 seconds before landing. They get super unstable aerodynamically. Now, why? Why do they get super able? Well, in order to get some aerodynamics affecting your vehicle, you need to be going fast, and the rocket's trying to do the opposite of that. So it gets a little bit unstable. It turns into a balancing act with the engines. What rocket can carry the most payload? In real life, Moose, or in Kerbal? Or like what like rockets that I've made? What are we talking about here? Dude, check this out. Okay. Oh, Mick and Kevin were driving around NASCARs. That's cool. Pop Bear, what's this? Relativity engine test today?
5, 4, 3.
Hang on. We interrupt your regularly scheduled Kerbal programming to bring you a real-life rocket announcement. This is a Kerbal space program interruption for a human space program update. In real life, Saturn V is the one that's moved the biggest masses into space, Moose. The Saturn V had a payload capacity of about 120,000 kilograms into low Earth orbit, which is just absurd. There's nothing. It comes even close to that. Not even close. The closest rockets that do come to that are the Space Shuttle, Buran, and the N1. The N1 didn't work. Buran flew once. It did fly cargo into space. It basically launched an entire functional cargo block, fully kitted out with extra parts attached to it in one shot. Buran Energia could move 100,000 into low Earth orbit. And then the Space Shuttle. The Space Shuttle could only move 25,000 kilograms of payload into space, but it's also moving a 60-ton orbiter into space as well. So think about like 60 tons of orbiter and 25 tons of payload. That puts you in the ballpark of like 80 tons to low Earth orbit, non-reusable, which is ideally not what you want with the Space Shuttle. Yet SLS still exists. Joking. I love SLS. Joking. It's a joke. Kidding. So yeah, Saturn V is still undisputed heavyweight champion. There's nothing comes close. Nothing comes close. Yeah, it's not even a judgment call. The Saturn V can move 5 times what a space shuttle could into space easily. Now SLS, remember, if we take SLS, right, which does exist, that rocket is absolutely a thing. It's sitting inside of the VAB right now. They're working on it. I know a bunch of people that work on it, actually, which is why I was just kidding about SLS. I still don't like the idea of throwing shuttle engines in the ocean, but I digress. Now, you take the space shuttle launcher, Moose, and you take the space shuttle out of it. That gives you an insane amount of payload mass for something that's pretty much already engineered, right? It's not a bad idea when you think about it. SLS in the Block 1 configuration, the one that we have right now, the dinky version with the crappy upper stage on top of it, that can move 100 tons into space. 100 tons out of the box isn't bad. I just wish there was some kind of solution on the table for a bigger fairing. Because right now, it can move 100 tons into space, but it can only carry the interim propulsive stage, the ESM and Orion, which that's useful, I guess, if you want to test out Orion. SLS Stockholm Syndrome? Nah, my big thing with SLS is that it needs a better upper stage. Once they get the upper stage on that thing, the EUS is being worked on. It's in CDR right now, Critical Design Review. Oh no, it passed CDR. They're working on finalizing all the drawings and stuff so they can start manufacturing the thing. It's just, NASA does that very quietly, that's all. How's the efficiency of the Saturn V though? Per pound of fuel to pay for the load? Now, Sup, before we get into the relativity footage, that's where this gets complicated. Is the Saturn V efficient? Well, by definition, the first stage is absolutely the opposite of efficient. The first stage is a top fuel dragster running extremely fuel rich, making as much freaking power as you possibly can. The first stage is probably one of the most inefficient first stages flying that ever flown, actually ever. I can't think of anything that's less efficient. The F1 specific impulse is like 263. I think only a solid rocket booster is less efficient than that. Even then, that's scraping the bottom of the barrel for efficiency. Like, that's pretty bad. Yeah, that's pretty bad. But here's the thing. There's only so many ways you can move 120 tons into low Earth orbit. There's only so many. Okay, let me rephrase that. There's only so many ways you can accelerate 120 tons of something to 17,500 miles an hour, or 28,000 kilometers an hour. There are only so many ways you can do that. So, the fuel being such an incremental cost in the whole scope of things, where rockets' efficiency and really comes into play, and this is what I talk about all the time, and this is how this plays into it. It's really more about the development and manufacturing, dude. That's really a better factor of efficiency here, if we're going to talk about it. It's not necessarily the efficiency of the motors. Obviously, if you used Hydrolox, it would be the most efficient, right? Like a Delta IV. Is a Delta IV expensive? Yes, absolutely. Because it's using Hydrolox, and that's harder to develop around. So, it really comes down to how you're like not what you launch into space, not what vehicle you're using, but how that vehicle is implemented. Another example in a case of like where this applies is like the space shuttle. The only way the space shuttle was going to lower the cost of something to get into space is by flying a lot, right? Does the shuttle use anything particularly revolutionary? For the time, maybe the heat shield. The tiles, that's about it. Is there anything else on that shuttle that's super revolutionary? The shuttle engines are pretty damn good, right? They're pretty dang good. I'd say those are the two big revolutionary things for the time, but even the shuttle engines are derived from Saturn V J2s. The shuttle is a complicated system. The only way that complicated system becomes, more efficient, you ain't gonna get your efficiency on the, in the technical side of things. The efficiency for sending stuff into orbit really comes from employing stuff in scale. That's the only way. Like ICBMs are in the 60s were a really good way to move stuff into space. Do you know why? They were very inexpensive because they made a lot of ICBMs because we all wanted to blow each other up, right? 1B is the upgraded stage, Mark, yeah. A giant trebuchet? Hey, Spoon, what's going on? So the Saturn V is probably, I would say it's probably not very efficient on paper if you're looking at the numbers. Most rockets, by definition, aren't, because, like I said, you can't beat physics. There's only so many ways you can accelerate something so fast to get into orbit. And if you're going to accelerate a bigger thing, it's kind of a zero-sum game there with efficiency. It's like, I want to get to 17,000 miles an hour. So can I accelerate it to 16,000 miles an hour and have it be okay? No. Could I use a more efficient propellant? Sure. More efficient propellants, improving the actual efficiency on the vehicle, is going to cost you more money. And that inadvertently can be inefficient. Something to consider, right? I have a space science question. Why can't they use the manipulator arm on the InSight probe to clear the solar panels? Because the InSight arm Mata-Day is basically... I mean, how would you do that? How would you clean it? It would be like trying to dust off something with a marker. Or a screwdriver. I mean, you could. I mean, Mata-Day, you gotta remember, InSight is way past its expiration date. Yeah, a lot of the probes, I mean, even Curiosity, it's been down there for more than 10 years. That's way past its expiration date. Where all this stuff is operating on borrowed time. Spirit and Opportunity, before they left, were way on borrowed time. They expected those rovers, JPL foresaw that those rovers would be good to go for like, what was their original mission, guys? Like less than a year? Both of them lasted more than 10. Opportunity almost lasted 15, which is a hell of an over-engineer, but, I mean, it's Mars. You don't know. There's no way to test that, you know? Is MLV a Minmus launch vehicle? No, nearly. It stands for Medium Launch Vehicle. 90 souls only. Yeah, they both lasted like 10,000 souls, Hip, right? So the cost per ton to space, not the cost per fuel to get into space. Bingo. That's the big thing. That's the big one, Sup. Reusability favors scale in this particular case, and that's the approach that SpaceX is taking. Reusability favors scale. If you can make something that's really quick and really easy to turn around, Falcon 9, boom, there you go. You know, but there's another component. The demand has to be there, right? It's not just necessarily lowering the cost per kilogram to get into space, because then you're projecting a market that might not necessarily be there, right? SpaceX solved that problem. How they solved that problem is Starlink. They made their own demand, and they made their own in-house service for an internet satellite constellation, and then they had the launch vehicle to work on reusability with. There's another revenue stream there, right? That's why SpaceX is bucking the traditional trend in the past, because making something reusable favors efficiency, favors your cost, right? Favors your cost per kilogram. But if you don't reuse it that much, then it doesn't. Space Shuttle. That's the problem that they had with the Shuttle program. You know, they basically got cold feet and a little bit of buyer's remorse with Challenger, which really sucks. But, I mean, that's what happens when 7 people die in a freaking high-profile thing like that. It's disastrous, you know? That's why, you know, just going back to it on a quick side note, you got to be careful. You got to be careful with this stuff. A good way to do it is the way that SpaceX is doing it. They are pioneering this new type of reusability with a rocket that doesn't need to fly with people on board, which is smart. That's a really smart way to do things. NASA probably should have done that with the Space Shuttle, but that's one of those hindsight is 2020 things. Yeah, exactly, Bandit. It's crazy, right? Anyway, let's jump back in. Let's see this footage from Relativity. I warn headphone users here. Relativity is doing a stage 2 duty cycle test. This might get a little loud. Headphone users. You have 5 seconds to comply. Stop or there will be trouble.
5, 4, 3, 2, 1, 0.
That's done. shot of the engine. Sorry, the game directory might not be exactly right, fellas. This is Human Space Program, not KSP. Human Space Program has way better graphics. They look positively real. That was a joke, in case anybody's watching me for the first time. Is this footage sped up? No, that's about right. I mean, nearly rocket engines do weird things to the atmosphere. Those gases are being shot out. You know what the messed up part is? Those gases are being shot out of that thing less than they're in the subsonic regime. Believe it or not. Yeah, subsonic. Look what it does to the clouds. Part of what's going on here, you're getting this violent freaking thing here, is because they're shooting water into the flame bucket to make sure they don't melt the flame bucket. You can see that there's a huge, like, it's called a flame bucket. Test stands have flame buckets in them. I just like saying flame bucket. I'm not going to lie to you. It's basically just a flame deflector that shoots the flames out off to the side. Now, don't get me wrong. Real pads have this too. But the test stands are overbuilt because a real launch pad only really has the flames going into it for maybe 5 seconds tops, right? And then you don't need to worry about it. These test stands are designed to take a full force rocket blast to the face for, well, 4 minutes in this particular case. So you need to deliver an insane amount of water. The plumbing for a test stand is absurd, guys. It's really that is a phenomenon in itself. If I do say so myself, allow myself to introduce myself. So the reason why you're getting these violent flames is because they're taking the heat energy from the gases being shot out by the rocket engine, and instead of the metal in the test stand absorbing the heat, they shoot the water into it. And the water is super conductive of heat. When water conducts heat, it turns into steam. So you get this violent thermal expansion here. That's what's going on. The water is absorbing that heat. Water actually can absorb heat really quickly. That's why power plants use it. Most power plants, nuclear, gas, coal, they use, well, even hydroelectric to an extent, they use water to either absorb energy, in the case of like a nuclear power plant, oil or coal power plant, or they store energy as potential energy in water and use it to turn a turbine. It's really, really efficient for generating power. Yeah, that's the violent thermal expansion going on here. You're getting a crazy expansion of gases inside of a vacuum, believe it or not. Now, what do you mean inside of a vacuum? This is on the ground, EJ. What are you talking about? Well, a vacuum is being generated right here. Yeah, vacuum is being generated. Look at all this. Look at all the ice coming off the stage. Look at all the ice coming off the stage. Look at all this condensation from the fueling pipes that's getting sucked down into the flame bucket. There's a vacuum going on here. So it goes from like super low pressure right here to super high pressure right here, shooting the water in, right? You go from super high pressure and then out the flame bucket, it goes back to low pressure. There's a lot of different physics happening right here. And rocket engines push the boundaries of physics. A lot of people say that. So sometimes physics does weird stuff like this when you really push the boundaries. Physics does strange things. It's like when a rocket's coming back for re-entry. Hey, here, let me listen to the. I want to listen to the engine shut off. Actually a really good throttle down, to be honest. It seems like they didn't cut the lines like other engines do. Usually rocket engines honk when they shut off. They go honk. It sounds like a goose. It sounds like a goose being slapped. Honk, honk, honk. I didn't hear that from this one though. So which rocket engine is this? This is the stage 2 of the Terran 1 rocket. It's the Aeon engines. I don't know if this is an Aeon engine, but okay, so the interesting thing about this is a company called Relativity Space. You see the stage right there? Second stage? See, obviously the engine in the very hot spot right there. Hey, don't slap geese. It's not nice. I never do. Entitled yonking. Takes an absurd amount of energy to turn liquid water to steam. And that's why it's really good at cooling. The rapid cloud is a function of exhaust mass flow, and the water vapor expands to 1,600 times the water volume, which is why you get the violent, thermals do be like that. You said it more technically than me, but yeah, bingo, man. Water's magical. Seriously. If you learn a little bit about like physics and stuff and chemistry, the fact that water even exists is kind of weird. Name something else that expands when it gets cold. There's not much stuff out there like that. That's very strange. Usually stuff contracts when it gets cold. Water expands and turns to a solid when it gets cold. That's weird. Yeah, that's very strange. There's not much stuff else in that we know on this planet that does stuff like that. Yeah, well, Stone Hobo, that works too. Yeah. Daily cursed rocket, and I don't hate it. What is this? Oh, no. No, I like that. Yeah. It takes more energy to phase change it to a gas than it takes to heat it before the phase change. And nerd rockets are something that give out a lot of heat energy. Just like any other just like any other thing with thermodynamics, you know, you're trying to achieve work of some kind. Usually, not all of the work gets used for what you're trying to do. Like a car engine, for instance. When you blow up gas and atmosphere inside of a combustion chamber, what is it like? What's the efficiency? Like 20% of that energy gets used to like, and don't get me wrong, it's gotten better on modern cars. Like 20-30% is getting used to push that piston up and down, and the rest, like the other 70, is just heat. Yeah, heat do be like that. Yeah, you can't beat thermodynamics. And that's what we were talking about a little bit before, right? It's the efficiency, quote unquote, from rockets doesn't necessarily come from like using a more efficient propellant. The efficiency from rockets comes from employing it in scale. Because, dude, you can't beat physics. You can't beat thermo. Thermo is an impenetrable wall. You can't get around it. 100% efficiency is impossible. You're never going to get in what you put out. Because what you put in, you're using to achieve a result. Right? Like a car engine, for instance, it's using an explosion, a combustion, to push that piston down. And don't get me wrong, there's always room for improvement, but most of it gets transferred as heat because you're combusting something. But there's really not many other good ways to get that piston to go up and down. Yeah, Crash, I'm with you on that one. It's weird, dude. Water's strange. It's a strange occurrence in our universe, dude. Antimatter be like, I'm going to be annoying now. Would water not expand while being frozen if we destroy the crystallic structure of ice, like compress and stir? Now, that's a chemistry question that I don't know, dude. I wouldn't be able to answer that. But what I would be able to show you is this. You guys hate that? I'll be honest with you. I don't hate that. That is a super heavy with two 5-segment SRBs on the side with an S2 Hydrolox upper stage and a Skylab on top of it. Now, I'll be 100% honest with you. This thing would blow itself up leaving the pad. Yeah. This thing would have 100 meganewtons of thrust. 100 meganewtons. That's 100,000 kilonewtons. So that's a lot of shit. That's like 1,000 shuttle engines in Kerbal. I'm fairly confident that this would not be able to handle. It would not be able to handle 100 meganewtons of force being pushed up on it, so it needs more boosters. Yarg, let me put it to you like this. If we could get this working, if Super Heavy could work with 2 5 segments next to it, Ares 5 be damned. This is Ares 20. And if we were able to get... You got... So, like, that means you're using Super Heavy as a core stage. Super Heavy as a core stage means you don't necessarily need 33 engines down there. You could have, like, 6. And it would work. Just the inner ring of engines. You do not need the outer ring. Man, that would be insane. This launch vehicle, if it could pass like dynamics of going into flight, like say, just let's play it off the notion that it could actually withstand SRBs and 33 Raptor engines going off all at once. That's one hell of an overpressure event, man. Let's just say it could do that. This vehicle could move like, I don't even know. What do you think? Like, we have 100 meganewtons, give or take here, of liftoff thrust, because we know Super Heavy is about 70,000 kilograms, and the SRBs both make 14,000. So that's 70 plus 28. We have 98. We have 98,000 kilonewtons of liftoff thrust. Dude, this thing could move like 500 tons into space easily. Yeah, Firework, I'm saying 500. I'd bet 500. You wouldn't get your Super Heavy back because you would need to be used like a core stage. Man. We need this. Dude, that's nuts. That is absolutely insane, fellas. Like, that is a crazy amount of force. I mean, dude, this could get the S2 with the Skylab to orbit easily. Like, easily get that into orbit. This would... Yeah. This would... See nut in tissue last post. What's that? Oh, sorry. I was admiring the ridiculousness there. I wanted to stop by and say thank you for streaming all these years. I decided to go for school for aerospace engineering in part because you stream, and last week I graduated with a BS in aerospace. I've accepted a job designing aircraft engines at Rolls-Royce. I will forever be grateful for you reviving my interest in air and space, and know you will do the same for others in years to come. It's good, man. That's awesome. Hell yeah. Thank you, Bandit, by the way. That's awesome, dude. I hope he's still here. I hope he was like, oh, he missed it. Bye. Hell yeah. Good for you, man. Feels good, doesn't it? Feels real good. You accomplished something pretty hardcore, dude. Not everybody can do that. You know what I mean? It's pretty skills. It's pretty skills, dude. Hell yeah. Awesome. That must feel freaking great. Hey, you got gifted a sub too. Anyway, Nut, if you see this, man, yeah, I'm freaking super proud of you for what it means, for what that's worth, like some random guy on the internet, you know, like, okay. That's really freaking cool, man. It's not easy. You're really excited? Thanks. Absolutely, dude. Good freaking job. Get some. And thanks for the sub. Yeah, there you go. It's pretty pog. Right on, dude. So, all right, Nut, my next thing that I need you to do, you know, since I've substantially motivated you, would be, can you design that for me? Can we do that? Can you just design this? I'll give you $1 billion in Monopoly money. Does that help? Yes. That's awesome, man. That's cool, dude. And for, like, aircraft propulsion. That's freaking sweet, dude. Yeah. Turbines are their own... That's a rabbit hole in its own regard, dude. I don't know, Nut, if you were here when I went down that rabbit hole trying to make using jet engines in KSP as a combustor, trying to make my own turbojets. We did. It worked. It worked. Worked pretty good, actually, right? You were here for that? Hell yeah. Dude, honestly, that was better than taking a class about it, man. I spent 6 months trying to figure out, like, how Moment works and how, you know, like, surface area of each turbine blade works and how, you know, you like with a helicopter, for instance, you can't just add more blades because that adds more moment. It makes the engine do more work. So it's not just about adding more blades. Like you have to increase power or torque specifically if you're going to do that, right? And the same thing applies for turbofans and stuff, which is really cool. Yeah, jet engines are pretty rad, man. Maybe if we score this house, dude, we'll find a junk turbo and we'll make one. That would be cool. Remember, you know, like we could make that happen. Like, operate it in the dang garage. We need someplace for the gases to go, but also, that's really freaking cool, dude. Yeah, jet engines, they're wild, man, wild. But I'm happy. I'm happy that I gave you the kick. That's cool. All right, I'm gonna get back to work, fellas. There are tons of surplus helicopter engines that the military has. Yeah, Bandit, helicopter engines go for like $5 to $6 grand. I could buy a lift for that, so I'll just go to the junkyard and find a turbocharger. I mean, ask Nut. A turbocharger for a car is just, it's a turbojet engine. It's just you take the combustor, and instead of having a combustor, you have an engine. That's it. There's literally no difference. Well, a big difference is that you're trying to make shaft horsepower with a turbocharger, and a turbojet you're trying to make thrust. So, little bit different forces apply here. But hey, Fabry, what's going on? Breaking news: Boston man burns down house making jet engine. Colin Furs did it, Geeson, and he did almost burn down his shed when he did. It's fine. If we score it, Bandit, I'm doing negotiations right now. Speaking of that, I should probably check my phone. Give me 1 second. Scary's asking me a question, believe it or not. Alright. I don't know if you want to wait till Space News to see this, but it's freaking comedic gold. We were rolling at work because it's true. The CEO of Ryanair says Boeing needs to get its excrement together. Bro. If the CEO of Ryanair is saying that, you probably should. You probably should figure that one out. It's got all kinds of money lines. At the moment, we think Boeing management is running around like headless chickens, not able to sell aircraft. And then even the aircraft they deliver, they're not able to deliver them on time. This is the CEO of Ryanair. Whoa! Freaking wrecked. Do you know how bad it needs to be for a customer to just like vent their dirty laundry out like this? I can understand why there may be various challenges manufacturing new aircraft, but the aircraft that you built and made 2 years ago, that all you had to do was put petrol in them and freaking fly them to Dublin. Really, I don't understand why you're taking 2 to 3 month delays on that. It's Redolin? Redolin, I don't know that word. It's Redolin a very poor management performance in Seattle. Boeing declined to comment. Oh, that's cringe, bro. Cringe. I'll go through the rest of that during Space News. Damn, dude, that's bad. Scan the lines with the... Either existing management needs to up its game or they need to change the existing management would be our view. We're happy to work with existing management, but they need to bloody well improve on what they've been doing, delivering to us over the last 12 months. We're a willing customer, but we're struggling with slow deliveries and an inability to do a deal on new aircraft despite the number of white tails they have sitting on the fricking ground in Seattle. Fricking for lack of a better word. Wow. If they get their crap together, we'd be willing to take more aircraft in summer 23 and 24. There's growth there to be won. You wonder what the hell the sales team has done in the last 2 years. Frankly, most of them seem to be sitting at home in their freaking gym jams working from home instead of being out there selling planes to customers. Oh, Boxy, this is the CEO of Ryanair. How bad does it need to be when the CEO... when the CEO of Ryanair is saying you fricked up? Moving the headquarters to Virginia from Chicago, well, may be good for the defense side of business, doesn't fix the fundamental underlying problems on the civilian aircraft side in Seattle. Damn, dude. I think it's fair to say that Boeing's just lost... Alright, damn. What a freaking savage, dude. Michael O'Leary's coming with the chair! That's... Dude, freaking ruthless. Wow. Alright. Okay, anyway, back to our hold down points. So, these hold down points worked, but I was seeing a little bit of jostling around that I wasn't really too incredibly happy with. Why? Why wasn't I happy with the... Well, I'll be honest with you. When stuff starts shaking in KSP, fellas, when stuff starts doing that, that's the game telling you that physics doesn't like what you're doing. Kerbal might not have all the answers for how to display certain types of physics, right? When stuff's moving around, it means that that part would be crushed in real life. Now, Kerbal doesn't have any way to crush a part. There's just impact tolerance, right? Impact tolerance is 14 meters a second, which means if it encounters a force more than 14 meters a second, the part explodes, right? However, the RCS balls, what do they have? 15. Now, this isn't a 15 meters a second impact. One, because it's not an impact, it's just being crushed. When stuff gets crushed, that means, like I said, it'll just jitter around. It won't necessarily crush itself. But I do know from certain past experiences that when you see that type of behavior, you should probably re-engineer something. Unfortunately, I absolutely learned that one the hard way, to say the least. Yeah. Is there a reason why the struts are not asymmetric? It's the collider on that ring. Yeah, the collider is all homing pigeon. No problem. Yeah, it's just the collider box. Yeah, usually when you see a crushing force like that happen, that means that a part is actually being crushed. And now, don't get me wrong, it might not be anything. But in a scenario where you have to dock, undock stuff, lock and relock stuff to get structural support in, like on this thing, for instance, yeah, that sometimes that means something is going to blow up. If you try to reload physics, if you try to time warping will pause the physics simulation, and then it'll immediately snap reload it. And snap reloading stuff will take parts that are crushed, and it'll actually up the, because physics is reinitializing, I guess. It'll actually shock load it, and shock loading it can break crushed parts, and that usually results in a gigantic honking Kraken strike. So these were good. They hold up this thing. They hold up the first stage fully fueled. What they don't do, what I don't think they're going to do, and where I think we'll run into problems, is if we try to make them hold anything else. So, where does that take us? So, okay, let's think about this for a moment. What's causing this thing to freak out? Well, the thermal bearing right here, the root of the thermal bearing, the place anywhere linear RCS port, that has a spherical collider, okay? It's a spherical collider. The reason why is that these things were designed to be a hinge. They were designed to move like this. They weren't necessarily designed for a compression load, right? They will work, but this thing is a ball collider riding on another ball collider. So if you're pushing down on it, what's it going to do? It's going to try to roll off the side. And that's putting a lot of pressure on the sides of these things. So what I think we should do, well, a couple of things we could do is we could take the load off of this and put it on something else, but the physics-less part is good to carry the load. Do you think with your recent discoveries that the big boy SSDO pad could be successful? Cumlin, I'm gonna give you the engineer's answer, and I'm just gonna go say it depends. I don't necessarily know if the testing that we're doing will fix the problems. I'd say they would certainly help them, but I don't know if they would fix them. I don't think Kerbal likes holding up 1,500 tons of something. Now, with that being said, I think one of the fundamental problems with the SSDO program in general is literally what I'm doing right now. I did not do any hold down testing with that SSDO because I was worried about cost. I didn't do any research. I just said, oh, we'll use auto struts, and that's it. This hold down mechanism, if applied to the SSDO, that could probably fix it if we come up with a stronger mechanism here. You gotta remember, that SSDO is 1,500 tons on the pad. It was heavy. And that's 1,500 tons with payload. That's a lot. That's a lot for KSP to understand, especially on a pivotal moving part. Now, with that being said, with this breakthrough, the Kraken Tech breakthrough, I could straight up mimic the hold down point mechanism from the actual SSDO. The actual SSDO didn't use a centered hold down system like this, like what I was doing. They had 4 hold down points that were pins with an explosive bolt. See that? That's these kind of keg looking things have the explosive bolt and frangible nut in them. So basically there's a bolt that screws into the back of Venture Star, right? And that bolt is held in, or the stud is held in place with an explosive nut, right? So the explosive nut cracks and the explosive bolt blows up and the explosive bolt falls down into here, right? And they try to contain the explosions inside of these boxes, right? I could do this. I could do this with the SSDO and we could make it work. I kind of want to prove it on the side just to be sure. Like, I kind of want to do that. But who knows? Maybe a cubic octagonal strut instead of an RCS ball because it has a flat surface. I think that might be a better idea. Yeah. I could replicate this and we could better disperse the load. Because, yeah, part of the problem, why do you think I know that fidgeting is going to cause an issue? I think it's possible. And what I would like to do as a side project, Canadian, is go mess with the small SSDO, because the big SSDO is just a scaled up version of the small one. Theoretically, and they both, because the hierarchies are literally mimicking each other, right? Like, the big SSDO, straight up in almost every metric, is just a version of the small SSDO that's double the size. For all intents and purposes, it's just 2 times the size. That's it. Actually, it ended up being like 3 times the size, but that's another story. The pad and everything works exactly the same way. And I know this because I tested the small SSDO's pad and the large SSDO pad, and they both had the same problems. The problems transferred between 2 different craft files if the vehicle was set up the same way, which once again shows that Kerbal is a absurdly accurate with its physics simulation, more than you might think. Where the simulation starts breaking down is that Kerbal doesn't show crushing forces. And I didn't know that. I didn't know that that's what that meant. Right? Like I said, something fidgeting around means it's having a force applied to it and it doesn't know what to do. It's like in GTA when you crash. When you like slam into a wall in GTA, the car doesn't compress. It's not beam. It doesn't crush itself. It bounces off, and that momentum gets carried somewhere else. Same idea, because GTA doesn't have any crushing physics in it, right? If it was beam, what would happen? All that energy would get absorbed by the car in the form of the car fragmenting into a million pieces. Same idea, but because GTA has no way there's no place to absorb that energy, right? Because the car doesn't crush itself. Cars are not as damageable in GTA as they are in beam, right? Though the car just ends up getting a little bit damaged and bounces off the wall. There's no way, those things are freaking out and there's no way to show that they're getting crushed. Like, there's no way to show it, but that's what's going on. Which is very interesting. So let's try to, let's mess with this a little bit. Let's get this like this, right? And just give me single symmetry, right? Let's place that here. Now, Celtic, you thought a cubic octag. That could work. Yeah, that could absolutely work. I'm thinking here for a second, though. Give me a second here. A cubic octag could work because it's flat, right? But what would we ideally want here? Now, we could do this in a couple of different ways. We can have this way, with the RCS ball sitting on top of the other RCS ball. That's good for a hinge. This is good for this type of movement, but it's not necessarily good for compression load. We already know that. And that's because these are two spherical gliders, so this thing wants to do this. It wants to move back and forth. And I'm gonna go ahead and guess that riding around on the top of the sphere like this is where that wobble came from when we tried to test this a little bit earlier, right? So we could replace this with a flat structure, like the cubic octag, like this, and then do a 6x thermometer around the cubic octag. That could work just fine. And then this thing would be sitting on a flat piece, like this. Where does the collider start on this cubic octag, just out of curiosity? Let me just look at it. The hitbox is down here. Okay. So this thing, where does the collider start on this? Right there. Okay. Yeah, absolute doesn't line up exactly. Yeah, an inverse spherical part, homing pigeon. Yeah, exactly. That's kind of where I'm getting at. We could make a cup, and we could basically make a ball joint. But a ball joint isn't necessarily what we're looking for either. Once again, let's go back and look at the Titan, right? So the Titan has a pin attached to the strut structure right here. The hold down points are right there. See it? Actually, the pin might be separated from it. I think it depends on the model. See what I'm talking about? There's the pins for it. How do we make
Discovery,
a
go
slot?
Good evening to all of you folks back home. Isn't this exciting? We're being seen all over the world.
Oh, yes, I know. 700 million people approximately joining us tonight. Some in summer, some in winter. But wherever you are in the world, the swimsuit segment will be sure to warm your hearts.
Our first group, our first stop, will be on the ground
So, Homing Pigeon, the other thing that I'm thinking is,
Chinese treasures dating back some 4,000 years.
Well, let's hit the road.
so these hold down points, a lot of them have like an interior slot like this, and then you have your pin, right? And the pin fits in, but the pin has a flange at the bottom. And it's not necessarily the pin that's holding the structure. It's the flanges butting up against each other. How can we make a strong flange like that that won't move? Because this structure right here and this structure right here is what's going to be pushing against each other. The pin is just used to align it. We're using the pin for structure, which might not be the right way to think about this. Why don't you put some parts on top of each other and undock them on the pad for a test to see how they lie on top of each other where a collider box really ends? I can do that nearly, or I could just look. I can see where the collider ends, dude. And I know what people are going to say. Well, how? Well, I have experience 3D modeling. That's my degree. I know this stuff pretty dang well. Basically, where the part highlight starts, if you try to look at something from an isometric view, and where the part starts highlighting itself is where the collider starts. I can see the collider boxes. I know what they look like. That, and I played a lot of KSP, so. How would we make flanges? How would we do that? And I'll add that we should use physics-less parts. The reason why we should use physics-less parts is because physics-less parts don't drift. They really don't. They don't drift very much. So why not use the thermometers as flanges? Are they strong enough, Firework? That's the real question. We can test it right now. Let's do it. So let me move these down to, right? And then let me select the thermometer, and then we move the thermometer. Oh, damn. Okay, get rid of those. Let me take the thermometer that's in single time symmetry, and let me move this up, like this. And now I need to attach this to a robotic part, right? We need to make sure that we apply the action group. There we go. I don't know if this is going to work. I think the thermometers are going to freak out, if you really want my honest opinion. I don't think that this thing will understand getting pushed down on like that too well. But I could be wrong. See, we have nothing to push against the flange here. Symmetry would be like, bleh, bleh, bleh. Alright. Let's go in here, go to our engine section. In 4X sim, let's take a cubic octag and let's push it down like this. Oh, actually, hold on. We need the... It should be able to be done with this too. We should be able to select the cubic octag, enable same vessel interaction because it's attached to the robotic, and that should carry over. But yeah, I mean, Canadian, going back to what you're saying before, I'm pretty damn sure we could apply some of these ideas. We could apply some of these ideas to to the SSTO. It's possible. Actually, you know what? Let's just mess with this straight up. Let's see what happens. This is using the thermometers now as our pinhole. Why can't the pin be rectangular or square? Use those two hots in a rectangular configuration. Well, Homing Pigeon, we could do that. I know that this is a perfect fit, though. These thermal bearings were engineered. The tolerances on these thermal bearings were engineered to work with Kraken Tech. They're very precise. I know that these are exactly touching the inside hitboxes from the thermometers are exactly touching that. A guy by the name of Josh Kernick in chat, he doesn't watch the stream too much anymore. I think he changed work, changed jobs or something. He came up with this and he precision engineered this for me. I know, and that was like after a week of testing back in like 2016, 2017. I know that these tolerances are super precise, and that's going to be more helpful when we like go to integrate the rocket. It has to be precise for the most part. So let's go give it a shot. Let's see what happens. Just out of curiosity. I think this thing is going to come undone. Honestly, I think it's going to break. I think the thermometers are going to start freaking out because us pushing down on the thermometers. Actually, you know what? It might work. Let's see. I am proposing using the 2 hots as the pin and a collidable part as the holster. That could work. It's possible. All right. So let's hit 1 and then undo the struts. I'm gonna go ahead and say that probably wasn't action grouped correctly. Yeah. Nothing collided. It just perfect. It just broke. Yeah. Enable same vessel because I replaced them. Enable same vessel wasn't enabled on these things. Okay, now it is. Save the crap file. Let's go back out again. Oh, that went well. We're engineering Ultio, yeah. Because it's like my... Now, don't get me wrong. If we just stopped at the SSTO and I started doing this, I would do it in mission mode. But I haven't played Kerbal in like 6 months. Like, dedicated played Kerbal in 6 months. So what I want to do is I've given myself some leeway. The last time I decided to jump into mission mode which was the first time I already had a vehicle engineered. So... Yeah, we're in engineering mode. I'm just messing around. And don't get me wrong, this vehicle probably will end up in mission mode. My rule is that, you know, because we're kind of restarting mission mode with a little bit of a variation on the rules based off of what I learned from the first run, I will still have to proof test this, but I will not pay for it. Just this once. Everything else you're gonna have to pay for. But I'm not paying for the testing because I'm trying to. Because honestly, if we ended up doing that, it would take months to make this thing. I'm kind of gonna do rapid iteration here because we've been out for 6 months, so I want to kind of catch up to where we would be. So faster prototyping. Okay, hit 1, disconnect the strut. What happens? Yeah. Huh. It slipped down through the pins, but the docking port, I think, the docking port in my umbilical was holding it in place. But it looked like it was just kind of sitting on the RCS balls there, so to speak. Okay, let me try something. All right. Leave those like that, because this might not work. Let me find another physics-less part in the science tab. Parts that we've used in the past that I know work well with Kraken Tech is this Vario fluid spectrometer. Actually, the first thing I need to do is attach it to here. And then we need to go here. Action group 1, enable same vessel collision. So now the SVI flag is on there. It's assigned to this piece. So what I'm straight up going to do is take this, flip it 90 again. see what this does. Alright, we're gonna hit one. Let's go right here like this. And okay. Now this is, with the other design, this is where we saw an insane amount of rocking before. This thing was rocking all over the place. Maybe homing, if we get to that point. It's sagging. It's sagging a lot, guys. Yeah, she's starting to really, really sag around. You know how I can tell? Look at the docking port up on the left. See? Those were lined up when we were unfueled, which means there is some compression going on here. There are parts that are giving. And I'm going to go ahead and guess that it's probably these. Because look, when we started, this bottom surface was at the top of the thermometer, which means we're getting a lot of sag going on here. Now, these parts are being compressed. What happens when we do this? Now the rocket is free floating. Oh yeah. And I'm going to go ahead and bet that if I time warp right now, this is going to explode. Ready? Let's flip back over here like this, and... Yep. Yep. So, what happened there was Kerbal, I time warped, and the vehicle was jostling around, and Kerbal thought it was flying. So because it thought it was flying, it didn't freeze it. See what I'm talking about? That right there, I'm pretty damn sure that phenomenon exactly is what caused the SSTO to explode on the pad. I time warped to try and get two pieces realigned, and when I time warped, the SSTO must have broken apart, and then the game thought it was flying, so it blew it up instantly. I'm pretty sure that's what happened. Kerbal Underground program. No, this isn't a rocket, it's just a boring machine. Alright. So I have another idea. It's very clear that these will hold, but the vehicle does sag. We need to remove sag from this design completely. So here's what we're going to do. Let me take this. That's the thermo bearing, right? Get rid of these. Take this. Put it back over here. Reapply the same vessel flags to it. Now, I'm going to have the wheel, the bottom RCS thruster, act like the bottom flange. Because it's boring. I'll show myself out. Alright, now we need to reapply SVI here. The flags are open, but they're not enabled on the thermometers. Okay, it's open there, that's fine. These triangles took me 2 seconds to make, screw that. I'm going to move these in. I'm going to move the whole thing in a little bit. Since you're building this in engineering mode, you will have to buy. Are you taking into a costed account to right now? No, I'm not, because I haven't played mission mode in 6 months. Nuclear, I'm trying to make up for the fact of what would take about 6 months of engineering. No, I'm not, and I'm just gonna put this in. We'll be able to. We're not paying for it. We're not paying for the design just this one time. Because we're implementing a new, slightly modified version of mission mode, which basically says that I do all the engineering instead of you guys. You guys choose the goal, I choose the engineering. I'm approaching it the same way I approached mission mode from the start. And the start was basically engineering the Imahara launch vehicle in engineering mode, and then going in. So no, I'm not taking into account costs here. I'm not taking into account testing. I want, basically I'm getting this rocket for nothing because, well, I could go engineer it in mission mode. It would cost us millions, and I don't really want to do that. I want to actually just sit and engineer a rocket to get my Kerbal editing skills back up to snuff. So, yeah. I mean, I would go back into mission mode and keep going, but I really want to make sure that this stuff is foolproof, and the best way to do it is the rapid prototyping in engineering mode. So, yeah, I really don't have a good reason. I should be engineering it in mission mode, but I took a 6-month break from playing KSP entirely, so I want to make sure that I'm game to engineer something. That and I enjoy doing this way. My advice would be to eliminate the RCS balls and use a square receiver. Yeah, well, I mean, homing pigeon, we could do that. But I'll be honest with you, I'd prefer to do something like this. The reason why is because I already know this is engineered correctly, and this has a lot of data behind it working. So it has a lot of data behind it working, dude. Yeah. That's all. For a different use case. Good point. Good point. I actually have another hold down point that... would actually work. Yeah, that actually might not be the worst idea. Alright, ready? I mean, as long as we're here in engineering mode, we could go and mess with a different type of hold down point. I'm sure we could figure something out, like the cup point that I'm talking about, or a flanged point would probably be better. See, here's the thing though. The RCS balls, they don't sag, which is very strange. Like, that's what I've noticed. They don't really sag too much. There's not a lot of play with them for whatever reason. The play is all sideways. Is MLV a 375 core? Yes. Mm-hmm. I'll tell you what, this one isn't sagging as much. But because the ball is riding on the other ball, it's doing this, it's shaking around. That didn't happen last time. I remember a stream a few years ago where we were making Kraken drives, so you could use the same force beating ideas from those flange points, for the flange points. What part specifically of the Kraken drive? Just to refresh my memory, dude. Okay, she's fully loaded out. Interesting. May I ask what you're making? Hold down points, Nasli. One of the big problems that I had with the SSTO is that I never really engineered the hold down points to work exactly right. It used a modified version of Freedom's hold down points, believe it or not, and that proved to not work. That's one of the areas I didn't do enough substantial testing with. And even though the vehicle worked great and the pad worked great, when the vehicle and the pad came together and tried to work together, they exploded. A lot. So you gotta be careful with that. Use an octagonal strut. Actually, homing pigeon, I know something that's very... I haven't... Pause. I know something that we could do. Yeah, we can make it work. Give me 1 second. I gotta get the space shuttle out. I gotta get Collins. Collins has an interfacing mechanism on the back of the orbiter where I used to bolt the external tank to. It's right here. Nope. Nope, that's the wing. There it is. Alright, get rid of that. These things. That could work. So let me just copy this. I'm gonna attach it right here, and then we gotta go into action groups again, and we gotta make sure that the set flag is on there. Enable same vessel. Enable same vessel. Okay, now the flag's applied to it. So all right, let's get rid of that. Get rid of it entirely. See, the only thing I'm worried about with this is that the interface on the vehicle is going to be a little strange because cubic octags don't exactly line up. So what I think I might do in this particular case is take one of these and do that. I know that seems like stupid, right? Like, why am I doing that? Now I know that this will bounce up against this and it'll push against the cubic octags. So now give me this, right? And that actually lines up perfectly. Now I'm wondering if we can we attach parts to the spectrometer? No, we can't. Okay. So let's go here. Make sure all those stayed correct. Make sure all of it stayed true. What about the RCS ball? Okay. Let's see if these shuttle style hold points work better. This is going to have a larger surface area, homing pigeon. It might actually do it. This might actually, yeah, this probably could get it done. Hey, Zimthi, what's up? All right, let's go in here like this. See what it does. The octagonal strut will work better. Oh, the actual octagonal piece, yeah. Okay. I'm trying to see if there's any off-the-shelf solutions before we go and engineer something different, you know what I mean? Alright, let's go in here like this. Hit 1. Next to no movement. Okay. Alright. Anything shifting? No. Let's undo the struts. Some of these didn't glide. It didn't glide. That wasn't it breaking. That was just no collision. Yeah, we're still reversed. I'm proposing using the O strut as the pin on both sides and the 2 hots as the walls or the flange. I don't, John. No. Oh, homing. Yeah, I see. You want something like this that's going around the octagonal strut. Yeah, I get you. If you have Kerbal open, I'd be curious to test that, but I'm not sure how well that's going to work. You're talking about, like, if that's the octagonal, putting thermometers on each end, right? And then, like, clamping around it, right? Hey, Evil Race, thanks for the party. Thanks for the party. I read the party. Thanks for the party. I appreciate it. No, thanks for the raid. Yeah. That might be too big of a hold down point here. I might not be able to fit it in with the landing legs and all that other stuff. Remember, this has to stay compact. Just like a real one. There's other things around. Are we gonna put in for this? NASA seeks input on Moon to Mars objectives. Input? Blue? I might, actually. Send them your craft files. Indeed. Alright, ready? And... okay. Yeah. Okay, homie. See, even with, I just noticed, even with this design, what happens when the rocket engines fire and the thing goes up? It hits the hold down. It'll hit that thing. It needs to be simpler than this. This seems to be working. It seems like spreading the surface area of the load to a wider surface area does work. That does work. Now, the question is, what's the minimum? What's the minimum surface area? Yeah, sure, Blue. If they have that 35, yeah. I actually am interested. Maybe, like, what are they asking for? They're asking for objectives? Let's write a report. Maybe it'll work, dude. Who knows? Did something just break? Alright, let's undock it. Wow. I was about to say that's really freaking strong that it blew up. Wow. That was boom. Oh. Wow, that broke a lot. Look at how bent it is. We're actually bending parts in KSP. That's pretty cool. Yep. That's not going in. Wouldn't be the first time that's happened to me. I did that on purpose. I induced it rocking back and forth to try and stress these points out. I just wanted to see what would happen. Those points seemed pretty damn strong for what it is. I mean, how much mass are we holding up here? There's 2, 4, 6. So 6 of the half tanks, which means we have 3. 8 times 3 is 24. That was 243 tons, give or take. And that's not including the engines. 7 times 3 is 21. So 243 plus 21 is 264. That was 264 tons that some spectrometers were just holding up. Not bad. Really not bad. I mean, to be fair, all of these have held that up. We had 6 thermometers and the RCS hold up 263 tons. That's pretty damn good. Can we eliminate variables and just make a tie down with weight on it? Maybe one engine? Maybe. Why not a 6-way configuration? Well, we got to be careful about hold down points, Firework. Now, don't get me wrong, there are different rockets. There are different rockets that have more than just 4 hold down points. An immediate example, if we go down to Huntsville, where we could see it up close, is a Saturn V. The Saturn I used 8 hold down points, if I'm remembering correctly. Let's go over to Huntsville over here. Huntsville actually has a Saturn I on display with its hold down points. How many does it have? 1, 2, 3, 4, 5, 6, 7, 8. Yep, it is 8. Good thing it's outside so you could do some visual research on it. Ow. I could get pictures of these up close, fellas, if we really needed to. I'm not gonna lie to you. I know people. Let me just say this. That whole spiel about the Space and Rocket Center keeping stuff outside. Yeah. Turns out there may have been more people that actually work at this place that watched the stream than I previously anticipated. So, yeah, let's just say we have a couple of ins over there. Just putting it out there. See, if I had my way, this would be inside. This would be inside. I would have the vehicle on its launch stand inside. Because frick you. Because that's amazing. They let you walk under it. Sure. Does that make you an influencer? I don't know, Jim. Saying influencer, saying that I'm an influencer out loud really just, it's gross. Hey, Alucard, what's going on? Yeah, River, I know what you mean. Yeah, I know. Alright, so we know that this system works. I'm just gonna put that over there. Ha! Influencer. Ouch. We could have the RCS and the thermometers on the rocket, oh no. That's definitely something that we could do. But I prefer to try and simplify this as much as possible. Simplify this part. So, actually, what I was thinking is we take the spectrometers and we make the spectrometers part of the pad. And homing pigeon for you too. This gives this thing something to ride on, a flat surface to ride on. That's the piece, right? This is the that's part of the rocket. And then if we move this down here like this, and this piece needs to go down. You are now an influencer. Where's your G Fuel?
Discovery, go at throttle up.
Maybe. Hey, Element. 49-month resub. Hey, nerd. What's up, dude? Yeah, but Claudeboy, what other influencer is going to tell you to not parrot their opinions? I'll be like 100% honest with you. What other influencer is going to do that? I'm the one that constantly says, don't be like me. You be like yourself. You know? But, yeah, who knows? See, the other thing that I've noticed, guys, physics-less parts don't drift because the physics of the part is being applied to its parent piece. So physics-less parts don't actually drift at all. They don't drift at all. Which is very interesting, isn't it? We could use physics-less parts as hold. I'm telling you, physics-less part will make the best hold down points because they don't drift. None of it drifts. Expect screenshots. All right, remember, Home Gadget has to be physics-less parts. I could use regular parts, but those parts will drift. I'm pretty damn sure. Yeah, that doesn't exactly align. All right, let's put that theory to the test here. I'm going to put 4 I-beams right here, top down. They're attached to the fairing. I'm going to put them right here. Collider's immediately there. This is a more static hold down point solution. I was gonna say, I do know that attaching these I-beams like this does attaching the I-beams like this, we did it with Neptune. It holds up Neptune just fine. So I'm not sure if that's gonna drift over time or not. Let's check. Serious. I had my first job interview in 3.5 years. I spent all of last night worrying about it. Turns out it was less than 15 minutes and all of the questions I planned for came up. Chance favors the prepared. Serious. Good job. What are you trying to do? What was it for? Don't tell me you're working at Tesco or something. I'll kick you right in the face. For my next trick, I will make the rocket disappear. Where did it go? I don't know. Oh, okay, and that makes sense. So new HLS design. Lockheed Martin took their ascent stage from the national team and made it into their own lander. Interesting. Okay, 2 things. 1, that was annoying. 2, I saw next to 0 deviation from this. This thing, that did not move. Like, nothing. We must go deeper. That actually held up pretty freaking well. Just a 3-6 month temp job as a porter. Oh, it's 2 to 6 month temp job. Nah, whatever. It's better than nothing. Bit piss. 44-month resub. I offset them 45 so I can undo the umbilical. How are any of them going to compete with Starship? Redundant dissimilar architecture, dude. They're gonna be competitive, Doom, because they're not Starship. Straight up. Tim's video with Elon, Doom. Yeah, the Elon interview part 1. They talk about the cargo bay and stuff. All right. What's our 89.990.3? Okay, let's make sure we can dock and undock and that doesn't piss anything off. No change in the booster. Back this out and then bring it back in. Now what? Now where are we at? 89.9, 90.4. Slight deviation. Let's time warp, see if it bent it back into position. 89.7. Something bent. Okay. Alright, let's fuel it. Go for gophers. Go for fueling, Victor. What's our vector, Roger? Check the clearance, Victor. Wait, that's not how that works. That's probably not what we want. Yeah, that's probably not what we want. Whatever happened there, that popped back into position. That one's dancing a little bit. All right, ready? Whoop. Interesting. So, I would say that this one is by far and away the strongest. But I am worried that these parts will drift. Like that. It definitely drifted. Oh yeah. So the regular parts are stronger, but they drifted. What happened there is when I went to redock, one of the I-beams slipped. Because it moved a little bit. They weren't completely true. It bent. And then it slipped off the side and the whole thing fell over. See what I'm talking about? This, believe it or not, that was stronger. Interesting, right? It's very weird. Strange, right? Interesting. Didn't we know about RCS nozzles and thermometers like 2 years ago now? Yeah, of course we did. So ask yourself why I would be using them again all of a sudden. Yeah, Zinty, I hope it'll be good, yeah. KSP 2, it should be fun. Then why would I use them now, all of a sudden? Think about it. What's the use case? Because Ringmill got you addicted to drugs and you forgot for 2 years. It's a weird way of saying I don't know. Doom, I found a way to use our Kraken Tech hinges with the robotics. Using Kraken Tech with robotics, I'm kind of pioneering a method here called hybrid tech. Hybrid tech is very good because we know that these hinges drift. They're not very strong. They're not strong. They bend, they flex. I've had problems with this with pads and equipment in game for a long time. The reason is because the hinges in the game aren't structural. Hinges don't have to be structural. These parts are meant for actuation. So you can make the parts, you could offshoot the structure somewhere else. But the strongest Kraken Tech hinges that we always made were ones that were made from physics-less parts. And we, for the longest time, weren't able to use physics-less parts for Kraken Tech until we figured something out. I know from the devs, from what Repo told me back in the day, that you can get physics-less parts to work. You can get physics-less parts to have same vessel collision. The key to do it is to attach it to a robotic piece. Now, that did help me with stuff. It did work. But the thing is that even if you have physics-less parts that are attached to a robotic piece, the robotic piece will still move. It still moves around. But I can get physics-less parts attached to any piece that I want. That's the big thing. You can attach it to parts that don't drift. Now why? Okay, so what? I can get physics-less parts to work as a hold down point or as a landing leg hinge or anything. And the reason I can do it is because we found a way to make that happen, and now we can make hinges that don't drift at all. I can make hinges that don't drift at all. because I don't necessarily have to attach all of the hinge to the robotic piece. I can have the housing for the hinge riding attached to a regular, riding with same vessel collision attached to a regular part, a part that doesn't normally drift as much. Thomas, excited for the sunrise launch tomorrow, especially since I live 35 minutes from 39A. I'm a little jelly. What are you in Port? That's Port St. John, right? Port St. John or Titusville? That's cool, Thomas. Yeah. Hey, Ernok. I missed the good old cubic octac days with the antenna and the thermometer hinges. Well, there you go. The antenna and their thermometer hinges work. They work just fine. I can make that all one vehicle. All one vehicle Kraken Tech hinges. So I can make the strongest hinges, and I don't have to worry about docking, undocking, docking, undocking. We don't have to do that. Understand? I put this to the test when we made a crane the other day. I made a crane with these hybrid tech hinges, and the crane was insanely strong. The hinges didn't break. And then I reloaded the scene multiple times, shut the game off, loaded it back up, flew another airplane next to it. Still no hinge drift. Nothing. No hinge drift. I can eliminate it. That's the big breakthrough here. That's why I'm using these thermo-bearing designs again, because we figured out a way to be able to use the Kraken Tech all as one vehicle. I can make hinges that are insanely strong, that will not drift. Because every time you reload the scene, the same vessel collision on the hinge pops it back into place. It reorients it automatically every time. And dude, look at how strong this is. Those 4 RCS balls are holding up all of this. That if once this tank gets tanked up, it's 260 tons. I have 4 RCS balls holding up 260 tons right now. The docking port isn't holding them up because the rocket is compressing down here. I'll prove that to you. Watch. Ready? Look, that whole thing is holding that whole sucker up. Ready? Let's undo the umbilical. Performance with one vessel should in theory be a lot better. More or less. Right off a US 50. I'm always speeding to get to launches. Realistically about 45 to 50 minutes. Right on, yeah dude. Colonial. I know. Thomas, I used to live in Winter Park. 50 goes through Winter Park. I used to live there a long time ago. But yeah, I know the area. Know the area pretty well. Yeah, Invoker. Yep. Yeah, used to live off of University Boulevard in Winter Park. Actually, right where Aloma, University, and Severin Boulevard all kind of convene, right? Because I went to Full Sail, so if you know the area, the Denny's on the corner of Severin and Aloma, I've had midnight pancakes there more times than I care to mention. How would that separate? What do you mean, how would it separate? Like that. See the pin come apart? How's stuff going? Negotiations or not? If I put a thermometer in between the two, does that stop the drift bug? There's not really a drift bug, Invoker. It's not a bug, and it's not a feature either. That's like saying, "Oh, my car hit a brick wall going 60 miles an hour, and now it doesn't work. Must be a bug." You got to think about it that way. Now, what do I mean? All right, well, let's take a break from this craft file for a moment, and let's go over here. So check this out. A little while ago, I wanted to make cranes. I wanted to make a lot of cranes because I thought cranes were cool. They still are, but I used to think that they were cool too. Thank you, Mitch, for that joke. It's never going to get old. So I would make stuff like this. And the way to strengthen the hinges to prevent them from drifting was to just couple a lot of hinges together.
Yo,
Yo.
I need you.
Oh, okay.
Phone call.
Yep. Guys, this is house stuff. I gotta take a break. Long story short, if you get a Kraken Tech hinge attached to the main hinge, it'll work. But I'll show you guys that in a moment. Just enjoy looking at the Chunguska. I'll be right back.
Discovery, go at throttle up.
March of 1989. Near normal precipitation, near normal temperatures in March, and above normal precipitation. An active storm track will keep cooking on the East Coast here in March as well. And the storm dates, the 5th and 6th, 10th through the 12th, the 16th through the 18th, 22nd through the 24th, and the 29th and the 30th of the month. That is our long-range winter forecast. If you missed any of that, we're going to do it again tonight on our 10:30 broadcast. Be with us. And you can also write me and include a self-addressed stamp envelope. Channel 11 here at 220 East 42nd Street, and we'll send you a copy of that forecast. Back to story. Back to story.
Discovery, go at throttle up. Discovery, go at throttle up.
Okay, fellas, I gotta take a break. I'm just gonna be blunt about this. I'll put on a video or something for you guys to watch. I gotta take a break for like 30 minutes. So, house negotiations. We're just trying to get everything kind of situated. Long story short, there are some things on the house that we're looking at that aren't necessarily up to code. And I'm trying to make sure, like, okay, what we found in the building inspection is some things that might need to be fixed in the future and some things that absolutely need to be fixed. Like, one of them is the electrical. There's some things with the electrical, not big things, but there's some things with the electrical that aren't up to code and they need to be fixed, like, immediately, because, well, electricity code, you probably do that. There's that whole letting the freedom out of the wires that makes fire, right? So, yeah, there's some stuff we need to, I basically, like, some of the stuff we can't really push for because sellers market, right? And some of the other stuff absolutely needs to be fixed. And I just got to make sure, if we're going to close on this sucker, I have to make sure that I have to make sure that all the stuff that needs to be fixed does get fixed, especially considering the amount of power that we use during the day. So I got to do some negotiations here real quick. There was something that we wanted to see here.